to speak to you about prefabrication and evidence-based design. So as Matthew mentioned, I'm from a company called Holmes Solutions. I'm also a board director of PrefabNZ. PrefabNZ are the New Zealand industry body focused at increasing the uptake of prefabrication techniques within the construction industry. But I'm mainly here today to talk to you about Holmes Solutions and what we do. So a little bit about me. I'm an engineer by background. After working as an engineer for a few years, I went and worked as a management consultant, helping people improve products and systems and eliminating waste. And now that's my day job. I help manufacturers develop strategy around designing better products and eliminating waste. So a little bit about Holmes Solutions. We are a product testing and development company. We work in high-risk industries. Now, by high risk, I mean anything where the product doesn't work properly and someone might come in harm's way, we get involved. So that's things like building and construction, transport, aerospace, health and safety, adventure recreation. It's a really diverse area that we operate in, and we do that for clients all over the world. We've got a really interesting team, engineers, technicians, researchers, and we develop products with a really hands-on approach. Because we have a big laboratory that looks sort of like this, where we test things. And we push products to their limits to find out how they work, and then we use that understanding to make them better. It means we do things like this on a fairly regular basis. So what we're doing here is we're testing the guardrail, not the Dodge Ram that's just clattered into it at 120 kilometres an hour, but we're testing the guardrail to make sure it works. And we prove that it works with physical evidence, because we find that when you do that, you can make things better. You can eliminate waste, and you can go beyond where theory and calculation say stop. It's a process we call evidence-based design. And it has a lot of relevance to building and construction. So we work with a lot of manufacturers of prefabricated components and systems, helping them to take advantage of this process called evidence-based design. We build sheds and push them over, that sort of thing. And I'll get into the detail shortly, but before I begin, a little bit of a warning. These next slides are deliberately meant to make you feel uncomfortable. I've deliberately set out to try and upset you a little bit and make you maybe even a wee bit embarrassed. And the idea is to be provocative and hope that you become interested in these topics and want to go find out more. So there's a lot to cover here. It's really just a brief skim over the top. We can have some good Q&A at the end. But anyone want to hazard a guess as to what that graph represents? We've got productivity on the vertical axis and years 1940 to 2010 on the horizontal. Anybody? Sorry? Affordability? No, that's productivity within the construction sector. No, productivity. So these statistics are from New Zealand, from the US, sorry, but they hold true for New Zealand and Australia. Flat productivity for over 50 years. That's not something I'm proud of as a member of this industry. How can anyone look at flat productivity for 50 years and be proud? It's scary. And it's really, really scary when you think about this. We are going to be 100,000 houses short by 2030, according to the current numbers. That's a lot of people without anywhere to live, because construction sector productivity is flat. If you do what you've always done, you'll get what you've always got. And we're guilty of that within the construction industry. It's even scarier when you consider this on a global scale. So globally, we've got to house another 1 billion people by 2030. How is that possible when productivity is flat? And so this graph here has got the world food systems. as the little engine that could. No, I think I can. We can probably put the world's construction supply chain in exactly the same position. I really hope we can. And we can't with productivity that looks like that, but we can with productivity that looks like this. Anyone want to guess what that red line represents? Come on, anybody. Technology, manufacturing. They've been improving at a rate of 3 to 4% for the last 50 years. And what are we doing if not manufacturing? We make things. Houses, schools, really important things. And productivity has been flat. Wouldn't it be much, much better if productivity looked like the red line? And so why prefab? What's all that got to do with prefabrication? Well, prefabrication is about taking a manufacturing mindset to how we build. It's borrowing from techniques in the manufacturing sector that could have benefits to us. And so in prefabrication, we talk about off-site construction. So you're making components, systems off-site in a factory-controlled environment, taking the benefits of a manufacturing mindset and then bringing them to site and assembling them. So it can mean a lot of things to a lot of different people. There's a bit of a spectrum here when we talk about housing. It can be anything from components, so frames and trusses, which we've done for years, but we haven't changed much in years, right up to complete buildings. So Keith A. Holmes kind of model, build a house, put it on a truck, drop it into place. New Zealand, we've been really good at the components in the whole building for the last wee while, but there's a lot that can be gained from this middle part. So it's things like this, which is a panel from the Considerham factory going into place. So manufactured, complete with windows, lifted into place, stand the panels up, put the ceiling on, place is watertight in a day. It's things like this. So bathroom pods, which some of you may be aware of. Anything that services dense, making a three-dimensional factory-controlled environment, improve the quality. This is the world's first open-source bathroom pod. It's actually a wall. It's a kitchen and a bathroom on either side. Good platform to build a house off. So you can use that in your designs if you want. It's also something that looks like this. So this is a wonderful building from Melbourne in South Yarra. I'm lucky enough to have been inside it. There was 6 months of site work for the first 2 levels, and then the apartments went up in 4.5 days. It's a 12-storey building up in just under 7 months. It's a Hickory Group project. If you've never heard of Hickory, go Google them. They do some amazing stuff. I've been inside it. It's a beautiful building, done in 7 months. So, in this country, we're pretty good at making things off-site, precast, steel fabrication, that sort of thing. What's different now? Why prefab now? Well, a lot of that's got to do with technology advancements, but it's also about the process that we take, and it's a different mindset, and it involves thinking things through in a bit more of a thorough manner. And so it's things like lean construction, which comes from Toyota. So if any of you are familiar with the concept of lean, something that I'm seeing a few heads nodding, that's good. So lean is a philosophy and a methodology that's about optimization and reducing waste. And so they define waste. There's 7 wastes. You can read them there. But waste is defined as anything that doesn't add value. So storage is an example. So you make something, put it in a box, move it over there, put it on a shelf, pick it off the shelf, put it on a truck. All that waste in packaging it up, putting it on a shelf, moving it twice. Why not just put it on the truck in the first place? Let's eliminate waste. Let's make things more efficient. And there's British research across all industries that have adopted lean, and they found out that on average, you get about a 25 to 30% improvement in productivity. That'd be nice with our flat productivity. You also get about a 30% reduction in scrap. Now that'd be nice, because 40% of our landfill in this country comes from construction waste. 40% of our landfill. So one of the waste is defects, so rework. Now, there's a whole another philosophy that goes around this, and it's called Six Sigma, which is a statistical convention. It's about manufacturing with reliability. And 99.99966% is an obscure number, I know, but I'm an engineer, I love numbers. What this means is 3.4 defective parts per million opportunities. Now contrast this with Brand's research. It says 89% of new homes have defects in them. 89% of new homes are built with defects. You can see we're borrowing from some of this Lean and Six Sigma type philosophy could benefit us as an industry. And there are people out now practicing lean construction. You can go Google it. You can find stuff out. It's there. Just borrow from the manufacturing industry. It makes life really easy for us. The hard work's been done. It's things that allow you to do this. So there's a couple of 737s. Boeing put them together in about 24 hours. 24 hours. It's about the size of a house, and they fly it. They sure as hell don't put up with 89% of new Boeings having defects. Why would we? An example a bit closer to home. So this is the new backpackers that went up in Belly Ave. This is an XLAM, cross-laminated timber project. Now, I was led to believe the site manager on this job claimed to be the happiest site manager in the country, because those panels, which were made in Nelson in the factory, just came to site and went together. No problems. So the site manager, who was used to all the firefighting and running around and fixing things, was just like, it just comes together and it works. So there are people out there now who are benefiting from this kind of approach. So that's sort of prefab, really high level. I encourage you to go find out more about it. Now onto the evidence-based design side of things. So evidence-based design is, as I mentioned before, it's using test results to develop your design capacities. And it fits really well with prefabrication, because if you're repeating components and you're repeating connections, then there's a return that can be made from the investment of testing things to find out how they work. And the New Zealand Building Code, if you just forgive me to talk about that for a moment, is a really useful document, because it actually makes provision for evidence-based design. And the reason it does this is because this is sort of the hierarchy of how structural design works. So you've got the building code, which then you have the loading code, AS/NZS 1170. And beneath that you have the various structural, material and connection codes, the concrete code, steel code 3604. Now when the authors write those design standards, so everything from the structure level down, they are extremely conservative. And they have to be by design. If you're writing the concrete code, you don't know whether that concrete's going into a 1-story toilet block or a 10-story building. So you have to assume the worst case. And that worst case leads to waste. So we've tested buildings built to the code and found out they're 3 times stronger than they need to be. 3 times stronger than they need to be. There's a lot of savings that can be made there if you do things properly. And 1170 says in black and white that you can use testing to develop your design capacities. So we do an awful lot of this, and I'll just take you through a case study now. Unfortunately, I couldn't get clearance to present on some of the housing solutions that we've done. Our clients are a little bit sensitive about confidentiality. But that's a picture of a broken concrete box culvert. It's a job that we did for Holmes a number of years ago. The price of reinforcing steel had gone through the roof, so they came to us and said, can you help us do this evidence-based design thing? So we got involved and we looked at the system and found out there were some conservative assumptions. So we redesigned it and we tested it. We put it through its limits, and we found out that depending on the size of the culvert, you could save about 50% of the reinforcing steel. So that was 50% extra steel was going into every box culvert. So that's excess material, that's over-processing, that's not sustainable. So we tested it, we proved it, and now they build more sustainable culverts. Now that holds true in whatever material. We've done that in timber, we've done that in steel, we've done that in concrete. There is always more than you need if you're designing using the old-fashioned way. So that was just a really quick illustration of how evidence-based design works. I'm hoping this is making you excited. So this is really, really powerful stuff if it's used properly, and it can kind of allow us to do the impossible because it's better. So you get better quality through prefabrication. Factory-controlled environment, you're not out in the wind and the rain and all the rest of it. You're getting better quality. So that alone is a good reason to do things. But you also get it faster. So international research says that you can have about 60% program savings using prefabrication techniques. So that's quite good when you've got productivity that looks like that. 60%, and that mainly comes from running activities in parallel. So you can be building the panels, the pods off-site in a factory while you're simultaneously doing the site works, like that hickory job. 6 months on site, 4.5 days for 12 more stories. It's also cheaper. So Brand's research says about 15% can be saved through prefabrication. 15% of the cost of the home. When we've done our evidence-based design thing, we find that 15% is just a given. You can go much further. So those are 3 great reasons to do anything, and it's safer. You're working in a factory, vehicle movements aren't such an issue, no ladders, lifting equipment's readily available. You can do things in a safer way. And then the thing that's really cool about that, it's greener. Just because you kind of get it for free. You're using materials efficiently, you're optimizing your process, you're just doing things more sustainably. I'll just quickly mention this job. This is the first lighthouse in Wellington, built by some Victoria University students. They entered a competition called the Solar Decathlon, where you have to design a sustainable house. They took it over to Washington DC, because that's where you show these things, and they got 3rd. And it was the first time a New Zealand team had ever entered it. Sustainable design, brilliant stuff. They've brought that back to New Zealand now, and it's a batch up in the Southern Hawke's Bay. So that was a bunch of students in 2010 taking advantage of this. So people have been doing this for a while. It's not that hard if you give it a go. And so I really, really encourage you to be interested in this. Go away, ask questions, start Googling. It's nothing to be afraid of. You know, ask me lots of questions. Go to PrefabNZ.com. The information is out there if you just know where to look. And if you need one final bit of convincing, anybody know what that building is? That's the Treaty House. Designed and built in panels in Sydney and shipped to New Zealand and assembled in 1836, I think. We were doing prefab before we were. Let's do more of it. Questions?